Hello, welcome to our series where we solve the questions in the WASSCE 2020 Dec Elective Maths Paper 1. This is the second video in the series. We've already solved questions 1 to 10, and in this video we're going to solve questions 11 to 20. Question 11 says we should express this surd in the form m plus n root p and determine the value of m. As you can see, this surd has been rationalized, so that's what we have to do to this one to see what happens to it. So we can write square root of 7 plus square root of 3 over square root of 7. We're just writing this again, plus 2 square root of 3. Now we want to multiply this by a number so that it becomes the denominator becomes rational, and normally you do that by multiplying by the conjugate. So you have 7 plus 2 root 3. If you multiply by 7 minus 2 root 3, that's going to do the trick. Having multiplied the denominator by that, we have to multiply the numerator also by that, so that we don't change anything. Square root of 7 minus 2 root 3 over root 7 minus 2 root 3, it cancels. So this is just like multiplying through by 1. And when we do that, what do we get? We get, for the numerator, we get square root of 7 times square root of 7. That is 7. Then square root of 7 times minus 2 times square root of 3, that becomes minus 2 square root of 21. Then we have square root of 3 times square root of 7, that becomes square root of 21 plus. Then we have square root of 3 times minus 2 root 3, that gives us minus 6. And then on the bottom we have a difference of 2 squares, so we have square root of 7 squared, which is 7, minus square root of 2 times square root of 3 squared, that becomes 4 times 3, which is 12. So we have that. We have to simplify this further. When we do, what do we get? For the top, we get 7 minus 6, that's just 1. And then we get minus 2 root 21 plus root 21, that is minus root 21. And then for the denominator, we get minus 5. So if you simplify this further, what is it equal to? It's equal to minus 1 over 5 plus square root of 21 over 5. That's what we get. So comparing this with m plus n root p, our m is this number, minus 1 over 5. And then our n root p is this square root of 21 over 5. So m is minus 1 over 5. Now, in comparing m plus n root p to this, what we did is to say that the number with the surd is n root p, so that corresponds to this one. And then the number without the surd is m, and that corresponds to minus 1 over 5. So that's the idea. The next problem is question 12. It says, find the coefficient of x to the 6th in the binomial expansion of 2 plus x all to the power 10. Now we can write the expression for this. We know that when we expand this binomial, if we want the term that has the power x to the 6th, is going to be precisely this. So this is the important thing to know. Can you write the term that has x to the power 6? And the answer is yes, you can write it. This is it. If you write it another way, depending on how you're expanding things, you can get this also, but the two are the same. So this term and that term is the same. This idea comes up a lot in the WASSCE, so you have to get used to it. And the reason these two are the same is that 10 root 6 and 10 root 4, sorry, 10 combination 6 and 10 combination 4, or 10 choose 4 and 10 choose 6, these two numbers are the same. You can use the formula to check that they're the same, but there's another reason why they are the same. I'll cover that in another video. So we now have to evaluate whether this one or this one. Let's choose one of them. So let's choose this one and evaluate it. What is 10 choose 4? 10 choose 4 is 10 factorial over 10 minus 4 factorial times 4 factorial. And what does that give us? Well, 10 factorial over 6 factorial, 4 factorial. What is that equal to? It's equal to 10 times 9 times 8 times 7 over 4 factorial. We could write that as 4 times 3 times 2 times 1, but I don't want to. 4 factorial equals 24. And we know that 9 times 8 is 72, and 24 divides 72 to give 3. So we have 10 times 3 times 7. 3 times 7 is 21. So 10 times that is 210. So to evaluate this, we have to multiply this 210 by this 2 to the power 4. 2 to the power 4 is 16. So what do we get when we multiply 21 by 16? Well, we get 6 here, and then we get that. That gives us 3, 3, 6. So we can add the 0 here, and that gives us our answer. Of course, you can punch this into your calculator and see that you get the same result. Some calculators can calculate 10 choose 6 and 10 choose 4. You can do that and then multiply by 2 to the power 4. The next problem is this, where we are supposed to evaluate some determinant. When you have this, what it means, the formula for the determinant is multiply this one by this one, and then subtract the product of this and this. So we have 3 minus x times 1 plus 2x minus 9 times minus 1, and this is equal to 0. So we expand it out to see what we get. We get 3 plus 6x minus x minus 2x squared. And then we have 9 times minus 1 is minus 9. It's 9 times minus 1 is minus 9, but we have minus here, so that becomes plus. Then we have to simplify further. We have a quadratic. The constant term is going to be 3 plus 9, which is 12. We have 6x minus x, that's 5x. And then we have minus 2x squared. So this is equal to 0. And we have to factorize this expression. We can, if we know how to do these types of problems, we have minus 2 and 12, and we want numbers that we can combine to get 5. We can do 4 times 2, which is 8, minus 3 times minus, or well, minus 3 times 1, or plus 3 times minus 1, and that's going to give us that. This is a well-known method, the method I'm using, breaking these down into factors and multiplying and adding to see what we get. But if you don't know it, you can let me know in the comments, and I'm going to cover it in another video. So what this means is that we can write, what can we write? We can write 4 minus x, and then 3 plus 2x equals 0. Now it's always a good idea to multiply back quickly to see if you get the result. 4 times 3 is 12, that's good. 4 times 2x is 8x, minus 3x, that's 5x, so that's good. Minus x and 2x is minus 2x squared, so that's good. From here we see that x equals 4, or x equals minus 3 over 2. From that we see that our answer is A. The next problem says find the sum to infinity of the geometric progression. Now the sum to infinity, if you remember the formula, it's always good to remember these things, is A over 1 minus r, where A is the first term and r is the common ratio. Here our first term is half and our common ratio is 1/3. So substituting those values here, we get half over 1 minus 1/3, which is equal to half over 2/3. And what is half over 2/3? Half over 2/3 is the same as half times 3 over 2, which is 3 over 4. So our answer is B. The next problem says if this rational function can be broken down this way into partial fractions, find the value of w minus v. Now partial fractions, a big topic in this exam, so you have to know how to handle partial fractions. When you have them written this way, you can do the straightforward thing where you multiply through. For instance, this 2x minus 4, x plus 3x minus 4 is what you get when you factorize this. So let me write that. X plus 3, x plus 3, x minus 4. Alright, this is equal to w over x plus 3 plus v over x minus 4. You can try to simplify this right hand side by rewriting it, and that's not the method I'm going to use, but I just want to talk about it a little bit in case you want to use it. So you have this. Now you can write a common factor, x plus 3, x minus 4, sorry, a common multiple. So that's a common multiple, and with that common multiple you can write the fractions over one denominator. So this becomes w, this x plus 3 cancels and you're left with x minus 4, so w times x minus 4, and then you have this one, x minus 4 cancels that, so you have v times x plus 3. Now when you write this, you write this equals this, then you observe that the denominators are the same. Actually, the equals here is 3 lines. It means that they are equivalent. It's an identity. And so writing it this way, it means that if the denominators are equal, then the numerators also must be equal. And when you write that, you're going to get 2x minus 4 equals what you have in the numerator here, and then you can go ahead and substitute convenient values for x and see what you get for w and v, and that's going to give you your result. That's one way, but there's another way, a shortcut called the cover-up method that I want to use in this example. The cover-up method can be used when you have linear factors, distinct linear factors in your partial fraction expansion or your partial fraction decomposition. And let me get rid of this. What it does is, again, we have w over x plus 3 and v over x minus 4. If you want to find w, what you do is you find what is going to make this denominator 0. In this case, it's minus 3. And then you go and substitute that minus 3 into the left-hand side after you've covered up this factor. So you imagine you have, let me make this more tidy. This is 2x. Let me get rid of this circle. Let's rewrite. What is going on here? All right, so we have this. Let me get my red pen. So 2x minus 4 over x plus 3 times x minus 4. What I'm saying is that we want to cover up this x plus 3. We want to pretend it's not there, and then we have 2x minus 4 over x minus 4, and this is going to give us w. If we put x equals minus 3 into this, it's going to give us our w. So how do we do that? We put x minus 3 here. We get 2 times minus 3 minus 4 over minus 3 minus 4. This gives us 2 times minus 3 is minus 6 minus 4 minus 10 over minus 7, which is equal to 10 over 7. So w becomes equal to that. Now, with the same method, we can find v. To find v, we cover up. This time we're going to cover up x minus 4. So let's do that. Let me write this again. We have x plus 3 Alright, so when you cover up x minus 4, you are left with 2x minus 4 over x plus 3, and you're going to substitute x equals 4 into that. When you substitute x equals 4 into that, what do you get? You get 2 times 4 minus 4 over 4 plus 3, and that's equal to 8 minus 4, which is 4, and then 4 plus 3, 7. So w equals 10 over 7 and v equals 4 over 7. So w minus v will become equal to 10 over 7 minus 4 over 7, and that's equal to 6 over 7. So our answer is A. This method I've used is called the cover-up method. The cover-up method, and it's a well-known method for solving partial fractions when you have linear factors that are distinct. and I'm going to cover it in another video just so it's clearer. The next problem is question 16, where it says events M and N are mutually exclusive, and the probability of M is 3/5 and the probability of the union is 2/3. So find the probability of N. Now, when two events are mutually exclusive, it means that they do not intersect, they are disjoint. In particular, it means that, well, I've already said it, but their intersection, M intersect N, is just 0. You cannot have the two events happening at the same time. If one happens, it means the other one cannot happen. Now, the general relationship between the union, or the probability of a union, M union N, is the probability of M plus the probability of N minus the probability of the intersection. So we just substitute the values into it. The union, we've been told, is 2/3. This is 2/3. The probability of M is 3/5. The probability of N, that's what we are looking for. And we've already said that the intersection is 0, so we can write this. This means that the probability of N equals 2/3 minus 3/5. And we can write this over a common multiple and get 10 minus 9. So 10 minus 9 is 1/15, and that gives us that. The next problem is the monthly salaries in Ghana cedis of 10 employees of a certain firm are as follows. We have these 10 numbers, and we are supposed to find the interquartile range. The interquartile range is the difference between the value at the 25th percentile and the 75th percentile, which these are also known as the upper quartile and the lower quartile. So we need to find these two values and find their difference. First, we need to arrange these numbers in order: ascending order, descending order. So let's do ascending order. The smallest is 110, so 1 1 0. Then the next, we have some 120. We have more than one of those. We can cancel it out. 110 is gone, 120 is gone, 120 is gone. The next is 130. So we have 130. Then we have 140, 140, 140. Let's cancel them. 1, 2, 3. 140, 140, 140. The next one is, we have two 150s. 150, 150, 150, 150. And then we have a 300. 300. Let's check if we have 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we have 10 numbers, so that's good. Now we have to find the interquartile range. We have to find the 25th percentile, or the upper quartile, and then the lower quartile. This is actually the upper quartile, this is the lower quartile. You normally, this is like the bottom 25% of your data, and then this is going to happen at the top 25% of your data. Now if you have 10 items and you want to find where the top 25% are and where the bottom 25% are, maybe we should start with 50%. We know that to get 50%, the 50% mark is going to be the place where you have 5 of your data on the left and 5 of your data on the right. So that's where this green line is. 1, 2, 3, 4, 5, and then 5 on this side. So the lower quartile is going to be where you have the midpoint of these 5 data points, and in this case the midpoint is going to be precisely that 120. That's the one in the middle of these two things. And then on the right side, similarly, this is your midpoint. So the difference between the two is going to give you the interquartile range, and the difference between 120 and 50 is 30. So that's our answer. All right, the next question is question 18. 3 forces, F1 equals that, F2 equals that, and F3 equals that. They act on a body, and we are supposed to find the magnitude of the resultant force. In a question like this, it's always good to draw a diagram, just so you know what is going on. So we draw a diagram. All right, we have the first force, F1. It's 8 Newton, and the angle it makes, we start counting the angles from the true north. So here it makes an angle of 30 degrees with the y-axis. So this angle is 30 degrees. Let me write it, 30 degrees. So this is F1, is 8 Newton. The second one is F2. It's also 8 Newton, but in a different direction. It's 150 degrees from here. So given that all the way down here is 180, we know that the angle it also makes with the y-axis, this angle is also 30 degrees. So 30 degrees, this angle. And this is also 8 Newton. So those are the first two forces. The third force is 10 Newton and 90 degrees. So here we have this 90 degrees from here is precisely this x-axis, and the force is 10 Newton. And we are supposed to find the magnitude of the resultant force. Now the force F1, this 8 Newton force, and the other 8 Newton force down here, they are exact mirror images of each other. What that means in particular is that the vertical component, we can resolve these forces into the vertical component and then the horizontal component. The vertical component of this force is going to point upwards, is going to have some magnitude and is going to point upwards. The vertical component of the 8 Newton force down here is also, this time, is going to point downwards with a certain magnitude. And the observation I want us to make is that the vertical component of this force is going to have the same magnitude as the vertical component of this 8 Newton force, and they're going to cancel out. So adding this force to this force, their vertical components will cancel out, and we're going to be left with their horizontal components, which are going to be in this direction. For the 10 Newton force, its vertical component is 0 and its horizontal component is 10. So we're going to be adding 10 to the horizontal component of this force and the horizontal component of that force. Now, what is the horizontal component of this 8 Newton force? We observe that this angle is 60 degrees. And so the horizontal component of this force is going to be in this direction. That is going to be in this direction, and when you complete this triangle, you want to find the magnitude of that force. The angle between this force and its horizontal component is 60 degrees, and using SOHCAHTOA, we know that this angle is going to be this force, or this length, is going to be 8 times cos 60, because cos 60, the cosine of 60 degrees in this case, is the adjacent, which is the force we are looking for. Let's call it G. This force over the hypotenuse, which is 8. So G is 8 times G is 8 times cos 60 degrees. And cos 60 degrees is half. So G is equal to 4. That means that the horizontal component of this force is 4 Newton. The horizontal component of this force is also 4 newtons by symmetry. So we have 10 newtons plus 4 plus 4, and that gives us 18 newtons. Now, this is not the only way of doing this problem. We could do a full-scale resolution of the forces and then try to add them, and then after finding them, we find the magnitude of the resultant. But that's going to be a lot more work, and this is more straightforward. So the trick, or the key points you have to know here, is how to resolve forces and how to recognize when you have symmetry. So if I tell you that a force is acting in this direction, true east or due east, and then this force is also acting due west, and I tell you that the force here is 5 newtons and the force here is 5 newtons, and I ask you to find the resultant, these forces are exact mirror images of each other, so they just cancel out and the resultant is 0. If this time I tell you that this is not 5 Newton but it's actually 4 Newton, then what does that tell you? It tells you that there's going to be an imbalance of 1 Newton on this side, so the resultant is just 1 Newton. So these are things you have to know, how to play with these forces, and then you can quickly resolve them as we did in this example. The next problem is question 19. It says 2 points P, 2 minus 3, and Q, XY are in the XY plane. The XY plane are such that PQ is I minus J, and we're supposed to find the coordinates of Q. If you recall that the vector PQ is the same as Q minus P, then you can go ahead and just substitute the values into it. By writing it this way, I've actually broken some rules. I really should write OQ and OP, but you get the point. You get this by just writing the coordinates of Q, which in this case is XY, and then the coordinates of P, which is 2 minus 3, and then PQ they said is IJ. IJ is just I minus J. I minus J is just 1 minus 1. So from here, what do we have? We can compare the X components, which give us 1 equals X minus 2. If 1 equals X minus 2, then X equals 3. So we know that X equals 3. Given the options, the only one with X equals 3 is this one. But let's just check if we get the same value for Y. The equation for Y is minus 1 equals Y minus 3. This means minus 1 equals Y plus 3, and it means that Y equals minus 4. So we know that B is right. The next problem is question 20. This is going to be the last one in this series. It says a stone falls from the top of a hill with a velocity of 18 meters per second. Calculate the distance through which it has fallen after t seconds. The distance can be gotten from the velocity by integrating. So if you call the distance or the displacement t, then, oh sorry, s of t, then you get it from the velocity by taking this integral. And we know what this is. It says it's 18t. So 18t, we have to integrate it. And when we do, we get, what do we get? We get 18t squared over 2. So you increase the power of x by 1, and then or the power of t by 1, and then you divide by the new power, and then you add your constant, and this simplifies to 9t squared plus c. So we have to see which of our answers has this. Now this constant c, sometimes you will be given enough information to see or to know what it is. In this example, we are told that the stone falls from the top of a hill with a velocity of this, and calculate the distance through which it has fallen after t seconds. So when t equals 0, the distance s of 0 is 0, because the journey at t equals 0, that's when the journey starts, and at the start of the journey we haven't covered any distance at all. So when we substitute 0 into this s of t, the answer should be 0. So when you put 0 here, what do you get? You get 9 times 0 squared plus c, and we're told that that's supposed to be equal to 0. Now 9 times 0 squared is just 0. So what this means is that our c equals 0. So the answer is indeed 9t squared. Well, this brings us to the end of this video. We're going to solve the remaining